tell from this problem, it can get very confusing. You do need to know your trig facts here, especially your SOHCAHTOA. I think that's super important for you to know. Hello everybody, welcome here to Cranky Calculus. We have our last video of related rates, which is going to deal with angular rotation. Don't forget to like and subscribe so that you can see more videos like this. So again, for the angular rotation that we're going to deal with, our steps are exactly the same as the other one. We're going to draw a diagram, identify all of the variables that we need, write out the equation that relates to everything, identify a helper equation. The only thing is, instead of this being a helper equation, this will be more of a helper picture. So let's get rocking and rolling to this problem. So for this problem, we have a man is walking along a straight path at a speed of 5 feet per second. The searchlight is located on the ground 24 feet from the path and is kept focused on the man. At what rate is the searchlight rotating when the man is 18 feet from the point closest to the path? So kind of a weird constructive problem here, but what we have going on is this searchlight is following this person and rotating, and we got to see at what rate this searchlight is rotating. So pretty much here's the picture that we have here. So we have this person walking along a path. Okay, we don't really know if it's walking towards or away. Okay, this searchlight, just kind of make it a dot, deal with it. And this searchlight, it says, is 24 feet from the path. And this searchlight is rotating as it's finding the man. So this searchlight is rotating as this person is walking across. And so we have this x variable because we don't know exactly, or we do know exactly this person is 18 feet away, but as this problem is going, the man is moving at a rate of 5 feet per second, which is increasing the x value. So we want to find exactly what's going on at 18. So what we're going to do here is we're going to relate these values, and it looks like this is going to be a tangent problem. A tangent of theta is equal to x over 24. Don't forget your SOHCAHTOA for the TOA. Tangent is opposite over adjacent. Opposite from the theta we have here is x, and then the 24 is the adjacent. So a couple of things here that we do know. We do know that dx over dt is 5, and we want this at x equals 18. So before I get to my helper equation, let's just kind of do the calculus here and see what we get. So we do want d theta dt. That is the whole point of what we're doing here. So take the derivative of tangent, and you're going to end up with secant squared theta. Tag that with the d theta dt, and that is equal to the derivative of x over 24 is the same thing as 1 over 24. Tag it dx over dt. So we have d theta dt on the left, dx dt on the right. I pretty much have everything. I just don't know what secant squared is. So this is where I come up with my helper. Instead of an equation, we're going to go a picture here, which will create an equation for us. So here's our picture. At this exact moment, this is 24, this is 18, and what I want to do is I want to be able to find secant of this picture. The only problem is I will need the hypotenuse of this. So only if I knew how to zoom in on my, there we go. I need to know my hypotenuse here, so I'll just call this c. So a squared plus b squared equals c squared. If you can tell, this is a Pythagorean triple here. This is a triple. This is a 3, 4, 5 triple, where I just multiplied everything by 6. So we're going to go 18, 24, 30. So c is equal to 30. Because of that, something to know this too, cosine of theta is going to be my adjacent over my hypotenuse, so my secant of theta is hypotenuse over adjacent. So it's helpful to know your trig stuff. So once we're here in this very particular problem, our secant of theta is going to be our hypotenuse, which we just said is 30, and my adjacent is 24, which does reduce down to, divide everything by 6, we're going to get 5/4. Okay, so come on right up here with this secant squared theta, and what we're going to do here is replace that with 5/4 squared And then we still have my d theta dt, which I do not know, equals 1 over 24 times dx dt is 5. So all we're going to do from here is just use algebra. So we're going to get 25 over 16 d theta dt is equal to, this is a 5 over 24. So these, from here, it's going to solve for d theta dt, but as you can tell from this problem, it can get very confusing. You do need to know your trig facts here, especially your SOHCAHTOA. I think that's super important for you to know. Let's go ahead and finish this up by multiplying by the reciprocal of, on both sides, 16 over 25. So this is 16 over 25. I can do just a little bit of reducing here, make that into a 6, make that into a, actually, no, I can go bigger than that. 8 goes into both of those, right? Sure. So since 8 goes in both of those, I'm going to make this into a 3. This is into a 2. Make that to a 1. Look at that, how important reducing is. That's a 5. So d theta dt, just by some reducing here, so simplifying, I'm going to end up with 2 over 15 radians per, units are important here. What is my searchlight? Radians per second. And that is going to finish up our video here.